Thank you for joining. I'm very excited to be here. You know, serverless promised us scale and simplicity, right? Which is great and which is true. But when you start to develop a complete serverless-based platform, then you need to remember that you must invest in security. The security, you're not going to get it out of the box. Part of it you will. But it's important also to invest in security, even though that you're actually developing a serverless platform. So today, in my talk, I will cover the challenges that we face when building JIT, which is a complete serverless platform. We'll cover the challenges and how we address those challenges. I will also share best practices and tools that I definitely recommend you to use. Okay, so I'm Aviram. I'm co-founder and Chief Research and Innovation Officer at JIT. JIT is an agentic application security platform. I'm a software engineer at heart. I've done development and research for many years. In the last 25 years, I was in cybersecurity, doing both offensive and defensive cybersecurity. And I was also part of teams building cutting-edge technologies in CyberArk and Sentinel-1. So I really want to bring my perspective on building serverless platform into this discussion. Okay, so just a recap. The classic model of the cloud basically states that the hardware and the visualization and compute and storage are all provided by the cloud providers. And there are some components where you need to take care of, right? Those are the operating system and the runtime and network and configuration. That's the classic model. However, with serverless, it shifts a little bit. And with serverless, the cloud provider is in charge of the operating system, right? And the runtime and the network configuration. But that doesn't mean that you as the user you are exempt from taking care of other stuff. There are important components that you need to take care of. For example, your code, right? And your customer data. And also IAM policies and access configuration and logs and monitoring and secret management. So all of that is still under the responsibility of us, the users. So in order to think about the security that you need to implement in building serverless applications, at JIT, we started to work with the OWASP Top 10. OWASP Top 10 is kind of a standard for it's a consensus for the most important risks which are associated with web applications, and we tailored it to serverless. So there are many risks which can apply to serverless. For example, we have the broken access control, right? For example, if you have overly permissive YAM permissions, which are associated with a Lambda function, or cryptographic failures or injection. Injection is something very critical with serverless because many of the actions which are taken care of in serverless models are based on events which originate from different sources of information. In secure design, which is associated with architecture flows, for example, when there is no threat modeling in place, you may make many mistakes which will impact eventually the platform. Security misconfigurations. There are many tools today that can scan your application in runtime and the infrastructure as code and flag out security misconfigurations, and we will touch those tools. There are more vulnerable and outdated components. For example, when you develop a Lambda function, you still rely on third-party components. There are tools which were designed specifically for those issues. For example, tools like OSV Scanner and NPM Audit and others. Those are great open source tools that you can use in order to detect vulnerable package when you develop your Lambda. Okay? And obviously, there are issues which are related to logging and to SSRF. We'll touch a few of them in the next few minutes. So let's talk about broken access control. If you define a Lambda function with a misconfigured IAM role, meaning it has access to more services and more permissions that it should, then that's going to be a risk. If, for example, that Lambda function is associated with an API which is public, then that's going to be a risk as well. So in the next minutes, we will cover many of those risks, which are focused on the broken access control, injection, security misconfiguration, and vulnerable packages and logging. So let's start with broken access control. Here, for example, you may have overly permissive Lambda functions that can allow unauthorized actors to read, write, and delete sensitive information. If you define those Lambda functions, or function in general, with overly permissive roles, then it can lead also to execution of unauthorized functions if you didn't mean to, or to data leakage. So in that case, the best practices would be to make strong authentication, to ensure that your functions are running with least privilege. You will see along the talk here that maintaining least privilege is highly important, whatever you do. And obviously to regularly monitor the logs. There are a few tools that I wanted to bring here, and so you'll be familiar with them. For example, PMapper. PMapper, it's an open source that it's focused on only AWS environments. It will help you model the different IAM roles, right, in an account, and to try and show you a path for privilege escalation. Okay? It will try to show you how an attacker can get to a certain service without any intention. Meaning the attacker can gain access to that resource in AWS by leveraging different YAM roles. Another tool that I recommend reviewing is RepoKit. Again, it's a Netflix-supported open source, and it will use the data about services which are used or not. And it will help you create a better least privilege policy for your Lambda functions. It will actually help you understand whether you're using those permissions. And it will help you make a better least privilege policy here. Another tool, which is an AWS native tool, it's called IAM Access Analyzer. This is a great tool provided by AWS. It will help you understand for each role which permissions are actually used. Okay? It will help you narrow it down to those services that you're actually using. So if you grant a permissive role, it will help you narrow it down to those services that you are actually use. It will also create findings. It will create findings whenever it thinks that you gave too many permissions for a certain Lambda function. So these three tools are highly recommended. Let's talk about event injection. You know, serverless apps are reactive by nature. They are triggered by events. Those events can come from SNS, SQS, S3 buckets, DynamoDB streams, and attacker can maliciously craft an event, and if that event is not properly sanitized, it will result in a behavior that is unintended. That can cause, obviously, resource exhaustion, privilege escalation, execution of unauthorized code, and data leakage. Our best practices is to validate and sanitize data input for every function, every Lambda function that you're using. Ensure that your functions are running with least privilege. Again, least privilege is super important. And monitor functions in runtime. Let me give you just one example that you can see here. This is a very innocent function which gets two parameters and then scans through a DynamoDB, right? Very simple and also naive. You can see that if an attacker will provide a wildcard for first name and last name, that's going to result in scanning through the entire DynamoDB table. That's going to create data leakage, of course, but also denial of wallet. Because if you do not have a cap on or timeout or cap on concurrency, then that's going to cost you a lot of money. So we're not just talking about data leakage, we're also talking about cost. In order to get alert or to mitigate those risks, we recommend using, again, AWS IAM Access Analyzer. It will help you analyze the permissions that you provided your Lambda functions. It will help you narrow down the permissions. Also, there is another great tool by AWS which is called CloudWatch. CloudWatch enables you to monitor, define and monitor different kinds of metrics in your AWS environment. So you can, for example, define a metric which is related to a spike in DynamoDB scan that will catch that. Or you can, for example, define a metric which is associated with large response size. So if now we are going to return the entire table, then you're going to see an evidence for it using CloudWatch logs. Let's move on to the next one. Security misconfiguration. Whenever you configure your cloud environment, there are tons of misconfigurations that can be in place. That can cause unauthorized access. For example, if you didn't configure the IAM role properly, denial of service and denial of wallet, also malware and ransomware attacks and data leakage. To do that, in addition to the IAM role configuration, we recommend defining max concurrency. So you can prevent an overload and abuse of your platform. Or timeouts. For example, you can limit your Lambda function in 5 minutes, 10 minutes, and by that you cap the execution time it will use. Let me just give you one example that we saw. So let's say, for example, you have a platform where you want to serve benign users. So the user, they submit requests and they are served by the different Lambda functions which are running in parallel. But we saw a bot generating malicious requests, taking up all the resources from the Lambda function. So the Lambda function will spin up, but they will serve the bot, and genuine request will be hanging. So again, this is an example of a denial of service and also a denial of wallet, because those executions by the Lambda function will actually cost you money. Two tools that I wanted to mention in here. Prowler. Prowler is an open source developed by a company with the same name. They run hundreds of rules for AWS, GCP, and Azure in runtime, and they flag out misconfigurations, many misconfigurations related to all the different services in AWS, GCP, and Azure. There is another tool called Kix, developed by Checkmarks, and unlike Prowler, it will scan the infrastructure as code. It will scan Terraform, CloudFormation, and other infrastructure as code technologies, while Prowler will do that in runtime. But both of them will run hundreds of checks for all the major cloud providers. So, for example, one check that is relevant for you, in this case, it can detect whether a Lambda function is associated with admin level permissions, okay? Or if there are two permissive YAML roles which are associated with different entities in the cloud, in the AWS account. For example, if they use wildcard in the definition of the IAM role. So these are puller and kicks. Both are very, very popular. Okay, let's talk about vulnerable and outdated components. When we develop our serverless platform, we're using, obviously, third parties. It makes sense. People worked on developing open source solutions, and we are leveraging those components into our application instead of just inventing the wheel. However, those third parties, they come with vulnerabilities. Many times unintended, but other times those third parties are developed by attackers, and then users just use those dependencies, and they are now becoming prone to attacks. So basically, if you're using third-party components, then it can lead to malware and ransomware attacks, of course, data breaches, and denial of service attacks, and basically all kinds of attacks once you're using basically a malware in your application. So the best recommendation in that case would be to scan for those dependencies. Many times the community discovers those vulnerabilities, and they are being published. And there are tools which are called SCA, software composition analysis tools, that will scan those components and will compare them to the knowledge that exists in the public databases. This is why it's highly recommended to use SCA tools to make sure that you do not import a dependency and introduce a vulnerability into your application. So don't use dependencies with known vulnerabilities, or at least scan your dependencies with an SCA tool. Also important to update your Lambda function to the latest version. AWS will not do it for you. It will deprecate, it will announce the deprecation of all the images, but it will not force you to update your runtime image. This is something that you need to do. Okay? Tools, open source tools that you can use and highly recommended are OSV Scanner, supported by Google. Supports all known languages, the most popular. NPM Audit for JavaScript. Dependency Check, mostly used for Java. And Nancy for Go. Let me just give you one example that I like. So there was a few years ago, there was an incident with a package named Event Stream. It used to be super popular, more than 2 million downloads a week. Very popular, but the maintainer decided that he doesn't want to keep maintaining it, and he actually transferred the publish rights in NPM to other user. That user was a malicious user, and it didn't want to publish that package as malicious. It didn't want to embed the vulnerability inside it. So what he did, he created other package, right, called flat map stream. Well, it was very unpopular package at that time. Okay, he added a vulnerability inside that package, and he made event stream use that package, okay, in a minor version. So it's really below the radar. People started to use it, of course, because it was very popular. And that is a classic supply chain attack, right? It led to millions of projects installing it through NPM, and private keys and funds potentially stolen from copy wallet users. The easiest way to cope with that vulnerability today, for example, or from the moment that it was published, is simply to run an SCA tool that it will flag out whether you're using that vulnerability. Okay, and the last one would be about security logging and monitoring failures. Again, I think it's clear that it's super important to implement logging mechanism. Otherwise, that can cause attacks to be undetected, and data loss or delayed detection and response Because if you do not have logging in place, then attacks you will not be able to notice those attacks. So it's very important to log admin events and basically all important system events. When you think about it, for AWS provides, not just AWS, but AWS also provides great tools to do that, like Amazon CloudWatch, CloudTrail, and Amazon Detective. So basically, when you think about it, I think you can see here an important pattern. So if we can summarize the golden rules for building a secure serverless application, then we're talking about sanitizing the events. We cannot just pull events and then do something with them. We need to make sure that they are safe and sanitized. We need to keep working in a least privilege approach, important more than ever. We need to scan for dependencies, doing logging and monitoring of events, and setting limits on timeout, on concurrency, and to generate budget alerts. Otherwise, it can go crazy. So if you want to start in securing a serverless application, you do not need to invent the wheel. There are already frameworks that you can start working with. For example, there is a framework called OWASP Serverless Top 10, released by the OWASP organization. For AWS, you have also the AWS Startup Security Baseline, the SSB, or the CIS benchmark, and also the AWS Well Architecture Framework. Okay? You can work with those guidelines in order to implement, to bake security into your platform instead of just inventing the wheel. Because people and organization and the industry and the community have already invested tons of time and effort in creating those guidelines and golden rules. With that, I wrap up. Any questions? Thank you.